Hello and welcome to another episode of our Post Cloud podcast, where we're talking about all things about the future of cloud. My name is Chris Krantz. I have been in cloud technologies for a number of years now, and I'm joined by my co host, Stephen.
Hello. I've been in system design, system engineering, and automation for a number of years. Um, this week, we're going to be looking at something that we're all familiar with to some degree. And we're going to be talking about storage arrays, specifically the good old enterprise storage arrays. Uh, we've both used these. I've worked at EMC in the past. Chris has worked with a whole bunch of different products as well. So we're going to be going over some of the history of these, why they were around, what problems they solved, and where they really lie in today's computing landscape with cloud and post cloud on the horizon.
Nice. Let's dive in, talk storage.
So, what is an enterprise storage array? Well, the answer is fairly simple. It was a performance band aid. To start off with, you had a lot of disks in your server, and you couldn't really get enough performance for some database that was growing and growing and growing, and you could only fit so many disks into a server. So the solution was to put the disks somewhere else. You put the disks outside the server and you connected them to the server, but you had to have a complex network because this was going to be a very powerful storage service. It was powerful at the time because it could offer you performance that was maybe thousands of IOPS, whereas a single disk was down at 150 to 200 IOPS. That's operations per second. We covered that in the previous show. And people needed this to run databases. So they hid the weaknesses of physical disks, which were doing 200 IOPS, in aggregate and got maybe hundreds of them and put them behind some kind of fan-in assembly that was called a storage array backend that took all the data and fanned it out to the disks or fanned it in from the disks. And they pushed it through a front end, which did a lot of caching and processing, added a bit of latency, but a small amount compared to spinning disks, and then sent that off to your server. And your server was suddenly looking at thousands of IOPS that it could never dream of if it had disks in its chassis, which enabled databases to perform really well.
From my perspective, when I started playing around with storage array, kind of mid to late noughties, around the popularization of virtualization as well. The other thing that the storage arrays were doing was fixing some of the inadequacies of the application. Databases were kind of the poster boy of enterprise storage arrays. Your databases, they were monolithic, so you couldn't really scale them out. So that performance that Stephen was talking about really was important to be able to get more out of them. But the other side of it was they weren't kind of self-resilient in themselves. So your databases weren't good. If you lost a database node, your entire database was off and offline. So what the storage system started doing was creating these snapshots or regular backups. The storage arrays would also provide RAID, which is kind of additional resilience and redundancy for those disks and the storage, which rolled up to provide that to the servers. Another core feature that a lot of storage arrays started providing was disaster recovery. So you wouldn't rebuilding the server itself wasn't too tricky. You could, and especially with the advent of virtualization, you would copy the entire server and all the data across to a second site, which was relatively cheap and easy to do at the storage layer. Whereas a lot of the application vendors were charging you quite a lot of money, looking at you, Oracle, with Rack and DataGuard and stuff. So it became a very cost-effective way of giving the business that business continuity. But then what happened was, as we've moved into this cloud world, cloud native applications, and we've started baking in that resilience directly within the application, the storage arrays started to become it's less required that we have all that. So if you look at most modern databases, we covered NoSQL in the previous episode, for example. Look at a lot of those applications and databases, they are fundamentally scale out. They are sharding and replicating within the database themselves to provide that native data protection and data resilience, even to the point of doing disaster recovery and business continuity. Some systems, if you look at things like Cassandra, for example, would even allow you to do that across multiple geolocations. So you can have an active database that is active in multiple locations. Very difficult to do at the storage layer. So we get to the point now where many modern applications, certainly if you're doing things cloud native or doing things in directly in the cloud, even private clouds, are really you've got that stuff baked into the application.
Well, and it's not just baking it into the application. In terms of the scale we'd get from a storage array, I mentioned that they've got some quite fussy, tricky to implement fiber channel systems, and those can scale to 50 or 100 nodes, but you typically don't go larger than that with a single array. And attempts to federate arrays throw you into a world of ever ratcheting complexity. If you try and manage multiple arrays and sync between them, you end up in a very messy bunch of code and proprietary solutions. Whereas if you look at cloud scale products, their scaling numbers might start at 100 nodes. That would be a typical deployment. Whereas on a storage array side, that would be the upper end of what a lot of storage arrays would typically support. And so you've got this dichotomy of the cloud scale being so much larger than the traditional storage array scale. It can't really bridge that gap, at least not within a feasible expenditure. Because another thing that was typical of storage arrays was the per gigabyte or per terabyte cost of storage on these systems was very high. And if you look at storage that you're doing with Cassandra or some NoSQL database, you're using disks in a server and you're paying a pittance compared to what you were paying on the storage array side. So you end up looking at the kind of Rolls Royce solution, except it's a Rolls Royce that's inherently limited and it can't hit that cloud scale. So that's what puts enterprise solutions at a turning point.
The performance piece you talked about earlier, Stephen, I think is also that has fundamentally changed. First of all, for the storage arrays to provide all these new services that they want to provide, deduplication, advanced snapshots, application level replication, all these sort of things, they ended up virtualizing the file system again. So you've got these disks with a virtualized with RAID that stripes the data crawl across it, and then effectively a virtualized file system on top of that. And if you wanted to federate that across multiple nodes, you're virtualizing again on top of that. And then you're presenting it up to something like Hyper-V or VMware or something else to give that virtualization layer, which is another layer of virtualization. And then maybe presenting up to something like Kubernetes or whatever. So you just got virtualization on top of virtualization on top of virtualization. And we've talked about before about the write amplification that happens because of that, certainly if you're doing application level protection. But it's also just the overhead of doing that. Whereas just using local disks, you don't need all those advanced features.
When we talk about the federation and combining multiple storage arrays and doing site-to-site links, that data was going through a number of hops. And anytime it went through a hop, some processing's happening. It's moving from one storage stack to another storage stack, from one link to another link. There is a non-zero cost for doing that, which means that you're adding latency. So your I/O to your hard disk might not have been that different. It could have stayed around 5 milliseconds, pretty kind of top end spinning disk speeds. Maybe you saw kind of go up to 5.2 if you had lots of features and array federation on. And that was fine, right? Because you were looking at a couple of thousand IOPS and your latency was under 10 milliseconds. It was all great. And then you move to NVMe drives now, and the latency is in the microsecond range. And so anything that storage array does is instantly noticeable, stands out like a sore thumb. That extra latency is crippling your storage performance with NVMe. And not just the latency, but the throughput, because the old NVMe drives that I have in my PC are rated at 32 gigabit, right? That's like PCIe Gen 3. The new ones are 64 and then up to 128 gigabit. Fiber channel networks are still trying to transition onto 64 gigabit links. So your server might have a grand total of 32 or 64 gigabit total storage performance going into it. And meanwhile, that can be saturated by a single NVMe disk. So why are you running this expensive network all the way back to a backend when your performance and bandwidth is now that of a single disk? It used to make sense when you had like an 8 gig link or a 4 gig link and your disk was doing, maybe under 1 gigabit per spinning disk, best case. And with random IO, it used to be crippled down to very low levels. That made a lot of sense. All of a sudden, you could funnel a ton of hard disks, spinning disks through that link. But when we get to NVMe and NAND devices, you're looking maybe 1-to-1, or maybe even less. Maybe you can't actually use the NAND device fully because your link's too slow.
It's amazing how kind of rapidly that changed. I think we've had solid state drives around for a lot longer than most people realize, but they didn't really start to give you that performance and reliability boost until maybe 10 years ago or 15 years ago or so. And then over the course of 5, 10 years at most, we went from hundreds of IOPS to thousands of IOPS to tens of thousands of IOPS to hundreds and now millions of IOPS out of singular devices. It really is crazy how much that has changed. It's not just simple things like having 128 gig on a little flash device like this. It's also just having that miniaturization and the performance boosting as well. So it feels like we don't need these big boxes with tons of fans taking up lots and lots of data center footprint. But I'm curious, Stephen. So, I mean, I do a lot of stuff in the cloud, and I know that you still kind of spend some time with customers dealing in bricks and mortar data centers, colo, those sort of private cloud systems. What are you seeing from a move there from traditional storage arrays to more modern ways of doing things? And are people still making that investment?
Well, there's going to be people on mainframes who will pretty much always be using storage arrays because they're kind of legacy technology. There's no path forward, and that's the fastest way they can connect storage to it. But by and large, there's a growing reluctance to stay on these products because the cost hasn't gone down over time. If anything, the cost has gone up. And it hasn't really matched what has happened with performance. The feature set has been largely the same for the past 10, 15 years with storage arrays. And software-defined storage, including databases, block, file, object-based systems, has caught up, whereas they were seen as the poor cousins of storage arrays and lacking in features when we go back to 15 years ago or 20 years ago. In the last 5 years, they're starting to eclipse the feature sets that storage arrays can provide. These products are now able to offer API interaction directly to our cloud infrastructure, whereas storage arrays, their one weak point was their integration with other systems. They didn't really do API interaction, which limits what you can do if you say want to run Kubernetes. You can easily talk to some software-defined storage system, which is just running on a regular CPU with your local disks, and make things happen from Kubernetes. Now, if you look at a storage array product, it's not going to have those API integrations. It's certainly not going to have them for free. You might have to spend a whole load of consultancy time and professional services engagement to make something happen, but it's not going to give you the same value as you would get from a purely software-defined solution.
I think one of the great problems we've had in the past is you have this storage array, and that's where all of our storage goes. Maybe you had a bit of a mix, and we've got some cheap disk and we've got some expensive disks, but a lot of the times it was just that's our storage array, everything goes on there. As you move to the cloud, you've got so much choice in terms of where things are going to go, even down to a singular database. If you're looking at your key value store, you might say, okay, this key value store is for caching high frequency access data. We're going to back it up with in memory. This database we need to boost it for Black Friday, so we're going to boost it with some NVMe based storage. This database is asynchronous access. It's populated by batch jobs. We're going to stick it on the lowest cost storage you've got that is available. It allows you to architect your platforms to be very cost effective, much more cost effective than you can do with kind of your one tool as a hammer and everything looks like it's going to be a nail. That's the approach to those storage systems where you don't have those choices or you don't have the flexibility of choices. Even the more modern ones that give you multiple tiers, it's not the same as having every single individual app you look at and you think, what is the best thing for this particular application? And I think that's one of the big shifts we've seen as people approach cloud. You can be much more efficient. I'm careful with my words there because I think a lot of people aren't. I think this comes back to, we're going to continually come back to this. This comes back to that mindset shift, looking at these different things and evaluating the different options properly to work out actually what is fit for purpose, not just what did I do before, but what is fit for purpose. And I think you always need to do that. And, in true nature of DevOps and failing fast, you can make mistakes and you can move things.
When we look at what's happened as the focus has moved from enterprise to cloud, the storage consumption has changed and it's become less about the storage vendors and the storage products, and it's become more application centric. And people are asking themselves, what type of data am I storing? And what does that require? Not which storage products are available and which should I pick. So the decision has become led by the data's needs itself, rather than, well, we've bought into this one vendor, so we have to use their product and make it work. I think cloud has really opened up a lot of choice, and it allows people to make more suitable choices. If they can get past the marketing and the hype, of course, that's always a big if.
I saw an interesting stat the other day. I think it was something along the lines of 90% of data isn't accessed after 3 months. And I think there's another element to this, which is kind of almost a green ops initiative, where folks are looking at the data that they're storing and the data that they're ingesting and archiving and all the rest of it, and starting to question, do we need that data, and do we need that data where it is? Now, a lot of organizations, a lot of businesses are very coy when it comes to deleting data, but they are starting to think about, where can I store that for long-term data retention, to kind of create myself a data lake of some kind. So then I've got this data available so I can query it if and when I want to in the future, but I'm not paying that kind of primary high performance penalty of storing it in high performance disks.
That type of migration approach has existed. It's just been one that has really been forced by whichever vendor you bought into. In my earlier days, I remember people were still putting stuff onto LTO tape, and you put a stash of those in a box every week and send them off to Iron Mountain or something. So if worst came to the worst, you could replay them all back and rebuild the business from scratch over a weekend. That type of tiering has always existed. It's just been a lot more complex and forced. And I remember seeing a lot of the backup products. I think you had to manually configure the retention periods and go into a GUI to do it. There was no API interaction. It was all very 90s technology. And I think a lot of that was born in the 90s and really did stay there until the cloud arrived and forced a massive shakeup. And everything was kind of reset, and they're now chasing the cloud and trying to get on to some sort of level playing field with it. I'm not sure it's going to happen, to be honest. I think we might start to see open source solutions that replicate proprietary cloud functionality be the path that people take to run storage on-prem, and the old enterprise storage arrays remain toys for those with the money to play with them.
I feel like there's also a shift in responsibility and ownership as well. So wind back 20 years and the storage team were responsible for the storage and the data architecture and stuff. Wind towards today, and I guess partly, possibly because of the DevOps movement, you've got developers and application owners are responsible for the full stack from top to bottom of that data. So are the storage team the right people to say, were they, to be honest, were they ever the right people to say this data should be here, that data should be there? In back 20 years ago, 30 years ago, it was the only way to do it. You didn't really have other options. Nowadays, because we've shifted that responsibility and that ownership, I think that there's a different approach. You can take a more application aware and application centric approach to this, because there's nothing worse than your application thinking that all your storage is available and pockets of that storage have actually been archived off somewhere else. And your application doesn't realize, if I access this data, I get 10 millisecond latency. If I access that data, I'm getting 50 millisecond latency. So doing things in much more of an application centric way seems to be a much more practical way of doing it. And you can be much more intelligent in the way you're selecting that data and what data should be archived, not archived, so on and so forth.
That makes a lot of sense. And what we're seeing is more opinionated solutions. So less of a blank sheet and you choose all of the options, but you're given something that works for 90% of the time. And we're also seeing less in the way of what the old Unix guys would call layering violations. A layering violation being the assumption you've got your application built in layers, starting with the hardware and working up till you get to the application sessions. And what you saw a lot in the 90s and early 2000s with storage systems was that the application would express an opinion on exactly how its data was stored and exactly how the storage system was doing its job. And so you had, instead of a series of layers, you had, if you imagine some applications just punching straight down through those layers and expressing opinions about things that were 2 layers below them, about how the storage array was doing its job, which the application should never have to care about. And in turn, the storage array would hide errors that were occurring and say, oh yeah, everything's fine down here, even as the red LEDs are flashing over half the room and power's dropping out, it would still be like, yeah, I'm just about holding on, everything's fine. And so your application wouldn't be able to make any concessions and maybe try and reduce the load that it was putting on the storage array. It would simply be completely unaware of that. So that the layering model didn't really work. And I think what we've seen with cloud is that a lot of software engineers have stepped up and started to say, it would be really useful if this storage could explain what's happened to it so that we can account for that and we can redistribute. Maybe we bring up a storage system in a new area and we start replicating out to that and building up a new storage area instead of relying on one that's failing. And it would be really great if the storage system would just offer a service and let the application be an application. In fact, force the application to be an application instead of providing dials and levers that the application can go into to configure exactly which disks are being allocated, because there's a right and a wrong way of doing that, and we should just be doing it the right way in the storage system to begin with, instead of having to hack around it and tweak it later.
Some great information, some great background on terms of where we're at and where we're at with storage and the different approaches to storage. Stephen, do you have any recommendations for folks? If you've got someone who's come to you, one of your customers, and so on, what suggestions would you make to them?
I think with all these products, don't be swayed by the big vendors. They've got great marketing, but the strategic vendor argument is a poor argument that's not going to give you great value. So always question what's out there. If you think that using a storage array is good for you, maybe because you've got a high risk application, make sure that you're in possession of all the facts. And for most general purpose applications, I would say that software is the answer here, whether it's accessing the disks directly itself, consuming them through a system like Ceph, perhaps. I've used a number of software defined systems in the past. They're available from a bunch of different vendors with different support agreements. Understand what your data needs and pick something that's appropriate to it, right?
So that's enterprise storage. In my humble opinion, I think we've gone past the days of needing it. And I think in the modern cloud architectures, if you're able to do it, which I fully appreciate, not everyone is able to do it and not everyone has got the need to do it. But if you're building modern applications, I think you can look elsewhere. And I think you can be much more cost effective if you're looking elsewhere.
As always, make sure you've got your eyes open and you're in possession of all the facts, and that way you'll have the best outcome.
Thank you very much, folks. If you're on YouTube, don't forget to like and subscribe. If you're listening to us on a podcast, again, appreciate a like and feedback. Love to get your feedback to see what you like, what questions you might have, topic requests, anything like that. Other than that, thank you very much for listening today. Speak to you folks soon.